Thank you. All right, so my name is Rob. My handle is Utkanos, which means duckbill platypus in Russian. And today I'm going to be talking about open source malware labs and how to automate them and how to connect different components together, and also how to use some of the components that I'm going to talk about. So who am I? Next slide. There we go. All right. I'm the Director of Research Innovation at Threat Connect, and I run the innovation team component of the research team. And we're responsible for finding new ways to analyze malware and analyze threats and come up with innovative ways to protect organizations. So why do you need a malware analysis lab? So there's a number of different reasons why you might need a malware analysis lab. And what I want to show you on the right side, this is from Lenny Zeltzer's Forensics 610 class. This is a graphic from that, and it describes the different stages of malware analysis and in increasing difficulty. So fully automated malware analysis is at the bottom, and then you have static analysis. And then the next step up is interactive malware analysis. And then the top most difficult part is full reverse engineering to know the capabilities and looking at the code itself. So what we're going to talk about today is the bottom two. So these are the easiest of the malware analysis stages, but these are also the ones that are ripe for automation. So one of the main reasons you would need an automated malware analysis lab, and this is the thing that I do, is malware research. So consuming files from a lot of different locations and consuming different feeds, and then analyzing them in an automated way and looking for C2 and other features of malware in volume. Also, if you have a one-off, if you need to research one particular file, this works as well. So you also can enhance your threat intelligence. So if you have a threat intelligence program, you can analyze malware from incident response teams. You can also analyze malware that's found from hunt teams. And then it's also one of the basic pieces of automated malware analysis is network defense. So you need to have a automated malware analysis system that's pulling files from network intrusion detection systems, such as Bro, and actually we'll talk about Bro in a little bit. But from network traffic, you also have email attachments, and then some host-based intrusion detection systems will pick a file that has been identified as either suspicious or hasn't been seen before, and then they'll send that into the central, either a SIM or somewhere else, and then from there, that file would need to be analyzed, and so an AMA is the way you would analyze it. And then finally, this is the main reason I like it, is it's a lot of fun. Malware analysis is really awesome. So I'm going to focus on 4 entry points in the malware analysis process. There's a lot more than this. There's many places you can begin a malware analysis process. But what I wanted to do is narrow it down to the 4 major ways that you can enter a malware analysis process. So you have a file. So a file can be any executable file. It could be a Flash file. It can be a Java jar. It could be a Word document. It could be a PDF. Basically anything that can execute code or through an exploit also execute code on a workstation or server. So those files are the first entry point that I'm going to talk about. The second entry point is a URL. And so when I talk about URLs, there's 2 just basic categories of URL that we're going to talk about with regards to malware analysis. There's a lot more if you're going to talk about phishing and credential drops and things like that. But what we're going to talk about right now is basically malware download URLs and then drive-bys. And a drive-by is where there is some form of exploit, and the user visits this URL, and then a payload is delivered without their knowledge. Sometimes some of the exploits are a little bit better and it won't crash the browser and they won't notice, but many of the drive-by downloads, it might crash your browser. But either way, malicious code has been delivered without any user interaction. You know, the user hasn't said yes to download something, they haven't run something, they've just visited a URL. Typically it's buried in an email, and a phishing email, and they may click a URL that looks like a LinkedIn request or something like this. So these are another entry point to the malware analysis process that we're going to talk about. And then the last two may be a little bit less obvious, but these are really rich ways that you can get more information about malware. So the first of them is a PCAP. And so PCAP is a packet capture. This is basically a recording of network traffic between 2 points in time. And so from that network traffic, you can learn a lot about the malware and what it's saying, what it's doing. And finally, a memory image. And so a memory image is exactly that. It's an image of all of the volatile RAM captured at one point in time off of a workstation or a virtual machine. And from that memory image, you can also learn a lot. You can learn a lot about what the malware, I like to say the memory image is what you can learn what the malware is thinking, and the PCAP is where you learn what the malware is saying. So to analyze these four types of data, we're going to look at 4 open source tools. All of these are publicly available. Each one you can download and install. And also contact me after this if you need help installing these, or if you need to learn more about them. I can point you in the right direction. So Cuckoo Sandbox is an automated malware analysis system. I know many of you that have used Cuckoo, you're going to say, well, Cuckoo includes volatility. But there's a nuance with volatility in Cuckoo that I'll talk about in a little bit. But the second one is Thug, and Thug is a low interaction honey client. So this is what you would use to visit a malware download URL to capture that piece of malware, or to visit a drive-by and hopefully trigger the drive-by exploit and then capture the payload. And then Bro. Bro is a network security monitoring tool, and many of you may be familiar with Bro, but we are not going to use Bro in the way that you typically use Bro. You probably use Bro as a network security monitoring tool. We're going to use it as a malware analysis tool. And these two things are slightly different, and you'll see why soon. So volatility is a memory analyzer. It's built in Python, and it analyzes memory looking for a variety of indicators. So you can find things that are different. You can also extract information from memory, and we'll talk about that in a moment as well. So the first thing we're going to talk about is Cuckoo Sandbox. So Cuckoo Sandbox provides static and dynamic malware analysis. And this is just a screen capture of one of my Cuckoo Sandbox instances. And if you're not familiar with a sandbox offers you a controlled environment where you can detonate malware safely. I would recommend that you put your malware sandbox off of your own network. Isolate it completely. I know some people who have begun using Cuckoo, they've downloaded it and loaded it on their laptop, and then all of a sudden, they've got C2 callbacks coming from their home IP address. So, make sure that you separate your malware sandbox from your own network. And when you begin, a good way to begin is actually to have a closed network and just observe the malware traffic without having it reach out to the internet. So this is a place where you can also get static analysis techniques. So static analysis basically comes for free because static analysis does not take as much resources as dynamic analysis does. So dynamic analysis, you're actually running the malware in a VM for 5 minutes, 10 minutes, or some amount of time. And so running an entire operating system, even if you're emulating it, that is a resource-intensive process. And so to look at certain static analysis features, static features in malware, that takes a very short period of time. So it's, there's no additional time for looking for strings and things like that. So you basically get it for free with Cuckoo. So I know everyone wanted to see something as long as a dynamic analysis, but you know what? Dynamic analysis is very obvious what you use it for. So dynamic analysis, you run the malware, it calls back to an IP address or a domain name or a URL, and then communicates with its command and control structure, and then you capture those indicators of where it's calling back to. That's pretty obvious if you ask me. So I wanted to focus more on static analysis techniques that you can use to get stuff from Cuckoo that can shortcut your analysis process. These are things that can assist you with looking around later in your analysis process. So one of them, this is a sample of Mac OS ransomware. This is called KeyRanger. And so I ran it through Cuckoo Sandbox and got back some information. And so one of the things when you're doing those later, more difficult stages of malware analysis is you need to reverse engineer the malware and get the assembly code from it. So to do that, you have to run it through whatever packer it was packed with. And so sometimes there are ways to detect the packer. Also, like you see here, I ran strings and it shows what packer was used, and then also which version. So this can actually be forged. I mean, I could go in there with the hex editor and change this, but malware authors are typically lazy, and so this is probably the true version of UPX. So now I know which UPX version to use to unpack it. And so I don't need to go figure out which one to use. Here you have AV detection. So for every file that you submit, you can also submit it to an AV scanner bank. And so these are AV detections that you get back from it. And these, sometimes you'll see something that's a very generic detection, such as the Kaspersky detection. But also ESET and Trend Micro, they have actually got a very specific signature for KeyRanger A. And so they tell you this is KeyRanger A. And because I saw two AVs that said the same thing, it's more likely that this is correct. Or, I mean, the other thing is they share signatures, so they share the same bad signature, but at least I have some idea of what this is. And so instead of just fumbling around looking at the malware, I can actually go to Google and get a shortcut and see if anyone else has begun reverse engineering this malware and has information that I can start with. Because if you've been hit with something and you're on an incident response team, time is of the essence. And if it means cheating and going to Google and finding someone else's work and using it, by all means, please do. So the next part, this is actually a different malware sample. As you can see, these are PE-specific, portable executable, Microsoft Windows-specific components of a file. And so I've run this through Cuckoo again and gotten back a few interesting things. So if you take these sections, and this is the .rsrc section, and take the MD5 of this, and then when you take the hash values of the sections in a piece of malware, you can find related malware that uses that same section. And so you can set up kind of families of malware that are potentially related. And so this is actually the MD5 that I used to search in VirusTotal for other files that are related to this particular PE file, and I found 52 other files. So now I have a group of files that I can send all of them through my automated malware analysis system, and then I can take features and say, well, this one's a false positive. I don't think this one is actually related, but this set is related. And then from there, I can gather maybe not just one C2 address. Now I have a set of C2 addresses. I have a set of domain names that I can now watch for IP changes. And I can look for other patterns that I can find more information about the adversary that might be running this particular attack. So in the same way as sections, and I apologize, this one, it ran over, this is a SHA-256 under the RT version, and it ran to 2 lines, just very long. So this is a resource in the PE file, RT_version. And so I found by running this through the VirusTotal database, I found 99 other files that are related and use this same RT version resource. So then I can take those 99, combine it with the 52. There was actually a lot of overlap between those two groups of files. And now I have an even larger set of files that I can analyze and find more information about what's happening to me in this particular file that I found. Now this last one, this is a really awesome technique, by the way. This is very, very awesome. So every PE file has a field. It's not always filled out. Some malware authors will just zero it out and it'll say, January 1st, 1970. But this is the compile and link time of the file. And so what you can do is if they didn't adjust this, if they have their clock set correctly, you can then compare this to the time that it was submitted to VirusTotal or submitted to Malware or submitted to whatever public sandbox or place that you've got that's collecting the data. And so as you can see, this was compiled and linked at 9:41 and 34 seconds, and then it was submitted to VirusTotal at 9:42 and 47 seconds. So my theory is that this did not go out to an email and infect someone and then someone take it and then report it to VirusTotal. This is the malware author. So VirusTotal gives you a hash of the submitter. And so now in the future, as this same individual submits other payloads for testing to VirusTotal, I can see those payloads and know about them immediately without them actually going out into the world and starting to infect people. So this is a very interesting technique. I hope you take it with you. So let's look at the different sandbox flavors of Cuckoo. And so we have plain vanilla. This is still the version 1.2 stable version right now. About a month and a half, 2 months ago, they released the 2.0 release candidate 1. So this is the next generation, and they're probably going to release the full 2.0 at some point this year. And Cuckoo Modified, this is actually a fork that was created by an individual that worked for Accuvant. And it basically fixed a lot of the things that he found wrong with the analysis in Cuckoo. And a lot of the changes, the modifications that he made have now been upstreamed into the 2.0 version. So what are the things that, that this gets you, Cuckoo Modified, over the 1.2 version? Normalization of file and registry paths. And this is actually very important for analysis, and I'll show you in a moment. But you get 64-bit analysis, service monitoring, you get an extended API, you can use Tor for the outbound connections, and then it has a Malware integration for looking at heuristics. So why is normalization important? So normalization of pathways is very important because those two paths at the top are essentially the same piece of malware dropping this, in the Bonzo directory that it created, and then the AID vfp.jpg. This is a file that was dropped by the malware, and then these are just two versions of Windows operating system. So if you want to have a variety of sandboxes and you're collecting data from a variety of sandboxes, you now have a problem for doing data analysis across these different flavors of sandbox. And so when you normalize it, you replace the unique sections of the path with the official environment variable, the recognized environment variable for that path location. And now you have one path for both of these sandbox flavors, and you can do analysis across a lot of different sandboxes. So Cuckoo Next Generation has a lot of new features. I'm actually going to kind of fast forward through this. You can see these slides later. They'll be posted online. And I've already given this talk at a few other BSides, so you can get the slides there. So this is Paranoid Fish. So Paranoid Fish is a way of discovering anti-analysis techniques that you have not corrected for in a sandbox. So many malware authors will put things into the malware which looks for certain registry keys or looks for certain features inside of a VM to know that this is a VM, or that this is a sandbox, or that this is a debugger and this sort of thing. So all of these anti-analysis techniques have been rolled into this executable file called paranoid fish or PAFish. And so what it does is it tries each one of these anti-analysis techniques while it's running in your sandbox, and then at the end it reports back, and it just basically displays this on the screen. And you can, if you have a screen capture of it, you can see you're okay on all of these things, wine detection, okay with VirtualBox, VMware, but they traced this one registry key which has detected that this is running in VirtualBox. And so this is the time where a malware would probably say, all right, I'm not going to do anything, I'm just going to sit here. So what you know now is how to correct for this. And so, this begs the question, how do I correct for all of these things that malware is going to detect? So there's another open source project called VMCloak, and VMCloak gets you two things. It actually dynamically builds your malware VM and installs software for you and installs the Windows registration key, but it also obfuscates all of these things that malware looks for as an anti-debugging and anti-analysis technique. So you can not only build your VMs in an automated way, similar to Vagrant. When you're using Vagrant, you just type Vagrant up, and then it builds your VM, and then after a while it's done. So this is the same sort of thing. You run the VMCloak command, you go get coffee, and you come back, and you've got a fully operational Windows VM, which is obfuscated. So what are the cuckoo outputs? So there's a number of different cuckoo outputs, but I want to focus on a few that are important for this talk specifically. So it's going to give you a PCAP file, and it's also going to give you a memory image. It's also going to give you dropped files. So dropped files you're going to want to send back to Cuckoo and have it analyze any of them that are executable. You also want to have a gut check in your loop there, because you don't want to have a piece of malware that writes a differently padded version of itself as a drop file, and then you're going to get into this nasty infinite loop of actually the same malware. So I typically say do about 6 deep, six children down, and then stop it, but then also alert, have a little alert for yourself to tell you, hey, this thing hit 6, maybe you should look and see if this is actually just dropping different copies of itself, or if this is some sort of strange new malware that actually drops 6 children before it hits a payload. So PCAP and memory image, like I said earlier, the memory image from Cuckoo is actually it's fine for Cuckoo's own analysis of the memory image. It's perfectly fine. However, if you're using some volatility techniques, Cuckoo uses some of the same techniques that malware does to observe malware. And so the CuckooMon component of Cuckoo actually pollutes the memory image in certain ways. And so it's better, if you want to have a clean memory image, to extract your memory image separately than running it through Cuckoo. So run it through Cuckoo, allow Cuckoo to look at its own memory image and the data that it can extract out of it. But if you want to do more analysis using volatility, you want to collect your own separate memory image from a clean VM that has nothing else in it, or from a piece of bare metal hardware. So let's talk about Thug. Thug is a low interaction honey client. And a low interaction honey client this particular one is written in Python, and it pretends to be a browser, pretends to have certain versions of Java, a certain version of PDF, and you can configure all of these. And it's basically pretending so that it can trigger a drive-by by being the vulnerable thing that malware drive-by is looking for. And so the goal is to capture the payload, capture the malware payload from that drive-by. And I like to say that, that Thug is a wolf in sheep's clothing. So one of the things that you can configure is the user agent. You can change the user agent to be almost anything you want. And these are 2 sites that I use when I want to configure my user agent and be a little bit stealthful. or try to find one that malware is actually looking for. So this top one is user agent string. This is just a library of almost every known user agent string. And then browserinfo.net user agents. This one is an individual who is collecting the user agent strings that visit his website. And so he ranks them in frequency of being observed. And so, for at least his sample size of visitors on the internet, it can tell you what is the most popular user agent string. And then, again, it simulates the variety of versions of vulnerable software that you can have as plugins. This is just a list of the variety of user agents and operating system combinations that are provided with it. The Firefox on Windows 7 I've found is a pretty good one. Also IE8 in Windows 7 is another very good one. So what are the output of Thug? It gives you a lot of payload files. So if it gets the payload, it gives you the payload. It also collects all of the different HTML and JavaScript files that get you there. And so you can analyze those. And one of the neat things about it is it arranges them in time. So you have the URL that you visited, and then children and the time that it visits them, you see the sort of family tree of what begat what, and then what begat what, and which loaded which URLs. There's a lot of other types of output, but the main thing that you're going to get from Thug is the payload files, which you're then going to send automated back to Cuckoo. And I wanted to mention one of these. I know that we're not going to be talking about this specifically in my presentation today, but HP feeds is really cool. So HP feeds is a publish-subscribe protocol. It's run by and published by the source code and everything is from HoneyNet project. And one of the individuals in HoneyNet project also runs a website called HP Friends. And so HP Friends is basically a social media site for malware researchers. And so you can sit there and chat with each other, and you can also publish and subscribe to each other's Thug and Cuckoo and other instances that speak HP feeds, and you can subscribe to each other's feeds of malware and malware data. It's pretty neat. So this is sort of one of my favorite parts of the talk. So I'm going to talk about Bro, and this is a network. It's a network analysis framework, but we're not going to really use it for its typical use case. Its typical use case is network security monitoring. So you would have it doing live capture and then looking for things that are unusual that occur on your network. We are not going to use it for that because I'm going to run something that I know is malicious and I'm going to listen to it using Bro. So Bro is a series of scripts. These scripts generate logs, and the logs are text files in it's a little bit like a comma-separated or space-separated text file, but there's a little bit more to it than that. And there's a very rich community that produces open source scripts, and so all over GitHub there's many other Bro scripts out there. For this talk, I'm only using the plain vanilla Bro scripts that come with Bro itself when you download the original source. So what I wanted to do here is just focus on Bro for a moment and not think about any other tools at all. So I'm tying my hand behind my back and only using Bro. So my analysis target is this Excel document. And I collected this from a free, open public malware sandbox called Hybrid Analysis. So if you wanted to later, follow along with my analysis here, you can download this file. The SHA one is listed. And I want to answer the question, what can I learn from PCAP only? So the first thing I do is I go to the connection log. So the first most important log that you want to look at in Bro is the con.log. And so con.log shows you each and every single granular connection that has been found in that particular packet capture. And so the first thing you want to do is get rid of the garbage. So most operating systems are going to have typical traffic that they naturally, just create as their, housekeeping and typical traffic that's all benign. So you want to remove all of that. So this is the operating system benign traffic. And so as you can see, there's some ICMP pings that occurred on IPv6. There's a little bit of IPv6 name resolution, local name resolution, and some broadcast traffic. So not worrying about this, so I want to just ignore that. This is important. So this is the typical DNS traffic, and so this is the malware trying to resolve two host names. So this is important. We'll come back to that. This is also important. It made 2 HTTP connections outbound on port 80 to these 2 IP addresses. And then this is the traffic. So Bro, being a network security monitoring tool, the output and the way you look at it is different than Wireshark, but the idea is the same. It is configured to understand and identify many protocols that are used, legitimate protocols. So here, if the service has a dash, this means Bro doesn't know what that protocol is. I usually call this the WTF traffic, and that is almost always C2 traffic from the malware. So let's look at the DNS log. The first thing you see here, the first thing you see here is it's resolved a query to s01.yapfiles.ru. And as you can see, it looks like this is either round-robin DNS or this is a fast flux botnet. But the thing is, I went and visited YapFiles, and I can see this is a file sharing site. And so I'm going to guess this is just this is a benign site being leveraged by the malware. So this second one, rmansys.ru, is interesting. So we're going to take a little bit of a look at that in a moment. But so I went and I looked at yapfiles.ru, and I found that this is a image and video sharing site for a Russian language image and video sharing site, and you can upload a file. So of course, I'm thinking, all right, so this is a little bit suspicious. So let's look at rmansys. So I go to rmansys, and I speak fluent Russian, so I can read the rest of this. But for you, see remote manipulator, that is very suspicious. This is in the same sort of vein of what I would still consider malware as Hawkeye, Keylogger, and things like this. That they're selling it as legitimate software. There's actually an office with a phone and people and printers, and the police are not arresting all of them, which they should. But this software is supposed to be the target audience of this software is if you want to put a keylogger on your children's machine, or if you want to spy on your wife or something like that. And so there's a gray area about that, but I consider it all malware. So now, remember, we're only listening to the malware. I have not looked at the malware file itself yet, but I now know perhaps how it's communicating. So it's communicating with that YapFiles, and I have a pretty good guess as to the identity of the malware. What am I working with here? So the next thing I want to do is look at the HTTP log. And as you can see up here, the malware does a get to s01.yapfiles.ru of a JPEG. But because Bro is smarter than your average computer program, it knows that this has a MIME type of application x DOS exec. So I'm going to guess that this is not a JPEG. So even though I said I'm going to guess, I'm actually going to go out and try to check it out. So I tried to load that JPEG in a browser to see if it actually loads. And as you can see, the image S01 blah, blah, blah cannot be displayed because it contains errors. Really? What kind of errors does it contain? Does it start with the characters MZ, maybe? I don't know. All right, so the next thing I want to look at is this. So this is the FUID. Bro is really awesome because when it finds one granular thing, like one row in its log output, each row is assigned a UID so that you can take that one row and relate it via that UID to other bro logs, and you can follow either that connection across different protocols, or if it downloads a file, in this case, I can go to the extracted files directory where it's carved all of the files out and dropped them. I can see which file it is that was dropped there. So I then go to extracted files and then run the file command to look for the magic string. And the magic string says that this is a PE executable. So this is definitely not a JPEG. All right, so now what I want to do is gather a little bit of stuff that I want to collect for later. So I look at the files.log, and files.log gives you the byte size of the file, and then goes ahead and creates the three hashes, so MD5, SHA-1, SHA-256. Now I want to look at the WTF traffic, what's going on here. And this is one part where I'm going to cheat. I want to replace this part of the talk with using T-Shark rather than Wireshark, but because Bro, you don't have a very good look at what the packet itself is. So what I've done is actually opened that one packet or one connection in Wireshark, and lo and behold, we've got XML C2 traffic going back and forth between these two locations. I know this looks a little bit like angry fruit salad, so I'm going to kind of spell it out for you here where, when I review what we've learned. So what have we learned just listening to the malware and not actually looking at the file itself? So we know that the adversary is likely Russophone. They use an Office document, and the Office document is generating network traffic. If you have an Office document and generating network traffic, that's bad, very bad. The payload is remote manipulator. The payload, we even have a TTP here, tactics, techniques, and procedures. So we've got they hide a payload as a public image sharing site as a JPEG. And then this stuff at the bottom I extracted from that XML we saw just a moment ago. And now this is very unique. I mean, I've got the license number for the C2 server that they bought from Remote Manipulator, its internal ID, Trojan version, and server versions. So now I can write a very accurate snort signature that will find this adversary's C2s when they reuse it with a different attack. If they put another payload out there and reuse their C2, I'll be able to connect that C2 back to this one. So this is a set of indicators that I've gathered from this. I've given them a couple of different ratings. YAP files, I rated this one skull, which is just suspicious rather than actually malicious, because it is a benign website. I did contact them and I said, hey, you might want to check that things are actually JPEGs before you allow them to be uploaded, but I didn't hear back. And this is actually on GitHub right now on my GitHub page. This is my Bro configuration. So this is my local.bro config file. And so please take this, use it. I spent quite a lot of time going through each and every config and making sure I know what it does and how to use it and how to configure it properly. So Bro gives you a number of different logs, and then it extracts files. Those files that you get extracted from here, like that payload, I would want to send to Cuckoo and do further analysis there. So let's move on to volatility. Volatility is a memory analysis framework. It's a very, very, very good way to extract artifacts from memory while the malware is running. And so it gives you a really good view into the malware. It's also a very good pen test tool because you can see, logins after reboot and fun stuff like that. I encourage you to look into volatility and use it all the time. It's really fun. There's also a tool in the recall project, which is similar to volatility. The recall project has a tool to dump running memory, so you can actually pipe memory into volatility while you're in the VM. So you're looking at live memory pages, which is very useful. And there's a version of that for Linux, for OS X, for Windows, etc. So it supports Windows operating OS X, and it also supports Linux. And what we're going to do again is the same exercise I did just a moment ago. And I'm going to analyze one piece of malware, but without looking at the malware file itself. I'm just going to look at what the malware is thinking in memory. And by the way, if you see an executable file that's like b.exe or 2.exe or f.exe, that's malware. That's almost always malware. So again, I encourage you to follow along with my analysis. Here you can go download a copy of this malware yourself. Same place, and this is the SHA-1 for this piece of malware. So one of the things, and you can look this up when I publish the slides later, but so I beat my head against this problem a number of times. I'm like, okay, I dumped the memory image from VirtualBox. Volatility doesn't like it. What's going on? So I finally figured out that you have to run, first you dump the memory image from VirtualBox, and then you have to use volatility to convert it to a format that volatility understands. And so you don't need to bump your head against the same thing that I did, so just follow this process and you'll have a perfectly good piece of, perfectly good memory image that you can analyze using volatility. So one of the first things that you want to do is take a memory image of the VM or the workstation when it's clean, so that you can compare some of the output from volatility. So one of the things that you would do is PS list, and PS list shows running processes. And so as you can see, I did the PS list from the clean memory image and from the malware memory image, and now I've taken a diff of the two outputs, and you can see, so search protocol and search filter and service host, these are all clean, these are part of the clean image. But now you can see explorer.exe is now running in this VM. And by the way, I did not run explorer.exe. I clicked on a malware executable. So this is very suspicious. So let's take a deeper look into what's happening there and run it through malfind. So malfind looks for process injection and anything that has been injected, and you can see explorer.exe, and again, you'll see a theme when you're using things like volatility. If you run one tool and you see, explorer.exe is running, then you run malfind and, oh, so explorer.exe was actually injected. So clearly it was injected. You've got .mz, which is PE executable. So PE executable was actually shoved into Explorer. And then I dumped those. So I dumped those processes and ran that dumped file through VirusTotal. And I found that Avira and Qihu360 have flagged this memory address as malicious, and then Qihu360 also flagged the second one. So both of those are found to be malware. Now what I want to do is look at the connections. So again, I can find what outbound network connections were made in that memory image. And so in the clean image, no network connections. And then all of a sudden, when I clicked on this malware executable, I've got these two connections. And so 216.170.126.105, now we have a C2 IP address. So what have we learned using volatility? We know that the sample that we observed uses process injection. We know that it injects specifically explorer.exe. And then we've also gathered a command and control IP address that we can then use to look maybe through passive DNS. This IP address might have further domains and host names that we can use to pivot out to look at previous attacks and get an idea of who it is or what organization or what malware family, or connect this particular attack with previous attacks. So again, the organizers said we're running late, so I'm going to kind of skip over this. This is something this is just tools that I find very interesting and useful in volatility. So you can come back to this from my slide deck. And then volatility, there's a lot of things that it will extract, but mainly you're going to be pulling DLLs, you'll be pulling processes. Sometimes if you pull a process that's in memory, you may need to reconstruct the import table, but there's techniques to do that. But you basically want to take any of those executables and then run them through Cuckoo. You may get URLs. One of the things that's cool is volatility can look at your Internet Explorer visit history. So kind of scary, but also you can pull URLs that have been visited there. So you might be able to, if you had a memory image from a incident response of a user and they clicked on a drive-by, now you can collect that drive-by URL, forensically collect it from that workstation, and then you can visit it using Thug. So I want to tie all of this together. And so I hope this is not too much spaghetti to look at, but I'll kind of explain it here. So you start with a file. You upload the file to Cuckoo Sandbox. It performs static analysis. It then performs dynamic analysis. At this point, the output from Cuckoo you want to upload to a threat intelligence platform. And then if it collects a URL or if it collects PCAP, you want to start and send those to Thug. You send a URL to Thug, send the PCAP to Bro, and then start their analysis process. So you process the URL, you process the PCAP. You want to have some logic in your queuing system where if you have seen a file before, you don't need to send it over here again. So if it has been seen before, you want to send the output of that to your threat intelligence platform, and then send, if you have not seen it before, you want to analyze it using Cuckoo Sandbox. I know that volatility is not in this set of swim lanes. That's because if you add volatility, it just all looks like complete spaghetti. But what I've done is I've separated volatility out, and you can on your own kind of logically combine these two, but visually it just doesn't work very well. So volatility, you upload the memory image from volatility, does memory analysis. If you've seen a URL, and this is basically the same logic over and over. If you've seen it, then take that analysis, add it to your threat intelligence platform. If you haven't seen it before, then analyze it with the next open source tool. So when you're orchestrating this and automating it, there's a number of different ways that you can have your message queue set up. RabbitMQ and Redis. So Redis is a memory key value store database. Excuse me. And then ZeroMQ is a distributed, very quick message queue. I prefer ZeroMQ. It's very clean, very fast. One of the things, again, like I've beaten my head against certain things in the past, and I don't want you to do that yourself. And so when you're transferring files among different systems, you want to use the message queue to tell that next tool, I have something ready for you, but you don't want to use the message queue to transmit the file itself. You want to use Nginx or Apache or something like that, and have the tool drop the file into Nginx, and then the message queue says, pick up file XYZ at this URL, and then have it collect the file using HTTP or FTP or whichever you want to use. Because those protocols are built to transfer files. It's cleaner, easier, and less headache. And then I use Elasticsearch to pull all of the data and kind of collect it. And so Cuckoo Modified has a Elasticsearch output. Thug has native Elasticsearch export. Bro, you can export logs in JSON format. There's a line in your local.bro which tells Bro to create JSON format logs. And then volatility as well, there's a switch in each one of the, when you run vol, there's a switch that says I would like the output to be in JSON format. And then I prefer to glue everything together with Python 3. Python 2 is dead. I hate it. It's gone. And especially like the way that it handles UTF-8 and character encoding. Stick to Python 3. So, do you have any questions?